Welcome to the digital communication session. Now in this lecture 3 we will do statistical averages. In the previous lecture I have discussed about the random variable, CDF and PDF. Now the next topic is the statistical averages. Now what is statistical averages? Are important in the measurement of quantities that are obscured by random variation. That will give you the additional information about the random variables. Now it will help us to find out the analysis of the random variable, and we can find out the mean of the random variable, nth moment, mean square value, variance and standard deviation. That will give you the additional information about the random variable that we have discussed. What is random variable? Which can take value from the sample spaces, and we have also discussed about CDF and PDF. That will help us to analyze the random variables. Now in further, statistical averages help us to do the further analysis of about this random variable. Now what is mean? Mean is also known as the expected value. Now for this random variable, the formula is minus integration minus to infinity x fx dx. It will give you the expected value. It is denoted by the small mx, or you can say by E, capital E and x. This is also known as the assemble. This will give you the expectation about the random variable. Now here you can see in this formula, this is the PDF. Small f is denoted by the PDF and the capital F is denoted by the CDF. Now this is x is the variable, that is the sample space value. Now here this is the formula for the continuous random variable. If you want to find out the mean of the random variable, then you can apply this formula for the continuous random variable. Now for the nth moment of x means random variable, now we can put x की power n fxx dx. The same formula of the mean, only is the different, we put the n here. Now if you want to find out the mean square value in nth moment, we can equate n equal to mid 2, then you can find out the mean square value. It is denoted by the ex square, and the formula will be x square fxx dx. That will give you the mean square value. This is another parameter that is help us to find out the additional information about the random variable. Now what is center movement? When n equal to 2 is there, the center movement is called the variance, commonly denoted as a sigma square. Now what is the variance here? Variance is denoted by the sigma square. If you want to find out the variance, it is the provide the additional information about the random variable, that is the randomness. How much is deviated from the mean value? Suppose this some graph is here, you can see the mean is here and how much is deviated from the mean value. That will give you the randomness, or you can say the deviation of the random variable. Now the mean is calculated by the x minus mx square fxx. Now here you can see mx is the mean. The formula for the mean, formula for the variance is sigma square, that is the mean square value minus mean square. In electrical terms, variance is the AC power, that is equal to the total power. This is the total power minus DC power. DC power, and this is the total power. in terms of electrical engineering, right? This is the mean square value. The formula for the mean square value I have told you, x square fx x dx minus mean square, right? Now, what is the standard deviation? The square root of the variance is known as your, the standard deviation is also known as the root mean square value, RMS value. You want to find out the RMS value of the AC component, that it is your standard deviation. You will do the square root of variance, it will give you sigma. This all parameter help us to find out the additional information about the random variables. Now, next is multiple random variables. Now, the term multiple is more than one random variable is there here. So, for now we have calculated for PDF is for the one random variable. Now, if another random variable is there, f, x and y. So, y is the additional random variable there. So, what will be the PDF and CDS for this? Here you can see this is the expression for the CDF, capital F x y x y. Now, it will be equal to probability of capital X less than equal to small x, and for the y is less than equal to small y. Now, similarly, the joint probability density function, that is the derivative of the CDF function. Here we are derivative with respect to x and respect to y. Now, the multiple random variable are basically multi-dimensional function defined as the sample space of a combined experience. Now, if you want to find out the PDF of a single random variable from the joint PDF, suppose this is the joint PDF is given fx y x y dx. Now, if you want to find out the PDF of the single random variable f y y, then we should integrate this joint PDF with respect to x. This is the joint PDF. Now, joint PDF will be integrated with respect to x, you will get the single PDF of y function. Now, if you want to find out the for fxx, now the joint PDF will be integrated with respect to y. If you want to find out the PDF for the random variable x, then we have to integrate with respect to y. If we want to find out the PDF for the y, we will integrate with respect to x. Here you can see this is the joint PDF. Now, the joint PDF integrated over one of the variable and one obtain the PDF of other variable, that is called as the marginal PDF. इसको क्या कहते हैं हम? Marginal PDF, or you can say marginal density. Next, note that now we know the PDF area is always 1, so the joint PDF is always area of joint PDF is always 1. If we integrated this joint PDF with respect to x and y, that will be equal to 1. This is the area under the PDF of the joint is equal to 1. And the CDF value, now we know that is 0 in CDF, because the experiment is not performed, there is no sample space value. Here also, if x random variable is minus infinity and if y is minus infinity, that will be give you the 0. Now next topic is our distribution function. This is the also another topic about the random variable, how our random variable is behaving. These are the some distribution function is there, standard distribution function. They are the predefined PDF. Predefined PDF means we know that how the random variable is behaving. We know how the random variable is behaving. We know the graph of the random variable. We have calculated the PDF for this random variable. So this is known as the distribution function, how the our random variable is distributed. Now there are two types I am explaining here for the continuous probability distribution. In continuous there is come uniform distribution function and normal probability distribution. Normal probability distribution is also known as your Gaussian distribution. There another type of distribution function is there for the discrete, that is binomial distribution and the Poisson distribution. In our course we will do this uniform distribution and normal probability distribution. That will give you the behavior of random variable. How is our random variable is distributed? Is the predefined PDF function. Now let's do the uniform probability distribution function, that is the for continuous time random variable. Now in this uniform distribution our random variable is behaving in a rectangular window. As you see in this figure, a uniform distribution whenever the probability is proportional to the interval length. Now the PDF of this uniform distribution function is fx equal to 1 by b minus a for the range of a to b and 0 for elsewhere. Now here you can see in this figure, it is this value is a, this value is b, and elsewhere it's 0, right. So PDF of uniform distribution is 1 by b minus a. You can also prove this PDF how it's calculated, 1 by b minus a. Now you know our random variable is distributed over this rectangular window, right. Now the PDF, the properties of PDF, the area under this rectangular window will be 1. So what is the area? You can see ये rectangular है हमारे पास, इसका एरिया निकालना हो तो लेंथ मल्टीप्लाई ब्रेथ. तो सपोज द हाइट इज हियर इज fx and the breadth is b minus a. तो fx multiply b minus a, it will be equal to 1, right. Now the PDF is 1 upon b minus a, as we have mentioned here. You can see from the properties of the PDF, the area of the PDF is always 1. We are equating this equal to 1. The area means length multiply breadth, fxx multiply b minus a equal to 1. Now fxx will be 1 upon b minus a for the range of a to b, otherwise it will be 0. Now a is the smallest value of the random variable and b is the largest value of the variable. Now other parameters we can also calculate for the uniform distribution function. Now here you can see x is a random variable which is uniformly distributed. From a to b. In random variable, first we have discussed about this random variable, then we have discussed about the PDF. Now PDF is the additional information about this. Whole topic is about related to a random variable. That is our noise in the digital communication. Now PDF is 1 upon B minus A for the range of A to B, right? Now in this tutorial lecture we have started with the statistical averages. Now more information about this random variable, that is our mean square value, variance, we can find out from this PDF. Is the more information about the random variable, more analysis of the random variable we have done, that plays the important roles, mean square value, variance. Now we can find out the mean here is calculated is out A plus B by 2. How we are getting this A plus B by 2? I will show you. The formula for the mean, this is the formula for the mean. Now here I am doing this here. Now here the limit is from A to B is having this section, otherwise it will be 0. So our limit will be A to B, right? Now what is the value of fxx? It's 1 upon B minus A, and x is the variable dx. Now you can do the simple integration here. One upon B minus A, it will come out of the integration because it's the constant quantity, and you can solve this. It is x square by 2 from A to B, 1 upon B minus A, B square minus A square B minus A and A plus B. Now this B minus A will be cancelled out, or mean will be A plus B by 2. Here I have mentioned A plus B by 2. Right. Now the variance of x. Now we will do the variance. For the variance, our formula is mean square value minus mean square. Now before calculating the variance, we have to find out the mean square value. Now here again we are equating the limit. Now b minus a will be come out of the integration. Simple variable is left x square. You can solve this. Right. Now this is the mean square value, and you know the mean we have calculated a plus b by 2. Now mean square value, this minus this, you will get variance that is denoted by the sigma square, b minus a square by 12. After solving this mathematical step, simple step, you can minus this b minus a, b cube minus a cube, from this a plus b by 2 square, because the formula here we can do the mean square, and it will come out b minus a square by 12. Right. This is the one distribution function, uniform distribution. There is another distribution function is the normal probability distribution function, is also known as the Gaussian distribution function. It also a predefined PDF will be there. The normal distribution function is the most important distribution function for describing a continuous random variable. It's widely used in statistical interference. It's been used in wide variety of application, including height of the people, test score, rainfall, scientific measurements. Now this is the graph you can see here. Is the uniformly distribution of a random variable. It's a bell-shaped curve. It's also known as bell-shaped curve. Now, if your mean is lies here, the variance will be the how much is deviated from the mean value. Now the PDF for this Gaussian distribution function, normal distribution function, predefined PDF is here. It is fx 1 upon root 2 pi sigma e की power exponential power minus x minus mu square divide 2 sigma square. Now what is here? Mu here, mu is the mean. Another term to denote mean is mu. You can also denote it by small mx. Here the sigma square is our variance. Sigma square is our variance. This is the formula for the Gaussian distribution function. Suppose or one of the example, x is uniformly not uniformly, it's distributed Gaussian. X random variable which is distributed Gaussian, we can use this formula here. Then predefined PDF for the Gaussian distribution. Now this will give you the relationship between the mean and variance. In this graph you can see some values here. Sigma square is 1, sigma square is 9. Now more is the variance, more is deviated. As you can see in this graph, variance is 9. It is more deviated from the mean value, that is 5, and when the variance is 1, deviation is less. Right. Now in this example, another example, when the mu is 15 or sigma square is 1, that is the variance. The more is deviated, more is the mean value. So that's it for the today's session. In today's section, we have discussed the statistical averages, random variables of the random variables, and the predefined function, that is uniform distribution function and the Gaussian distribution. In next section, we will do the random process. Thank you.